Hello, hello. Welcome, everyone. I'm Quinn. I'm a coach at Major League Hacking. I'm super excited to have you all here. I was just in Swiftstream about an hour ago to see the season launch and the new mascot. I hope everyone's still buzzing from that. I've really enjoyed that. And yeah, I'm super hyped for the season coming up. I hope you are too. Got some hellos in the chat already. That's awesome to see. Welcome, welcome, welcome. Let me know where you're all tuning in from. Have you had a long day, or maybe your day's just starting? For me, my day's been fairly long already, so this is going to be chill. We're going to do some learning. We're going to be using a toolkit called FairLearn, and it's actually one that I'm fairly new to as well. But I thought it was really cool, and so hopefully we'll learn a bit about it together. And I'm hoping that by the end of it, we'll manage to get somewhere really cool. And this will just be, by the way, a 1 hour stream, unlike most of mine, which are 2 hours. This will be a little bit shorter. So yeah, pretty laid back, and hopefully we don't run out of time. That's the challenge, isn't it? That's the challenge. Hello, welcome, welcome, welcome. I'm gonna give it maybe like a minute or two more, just for people to come in. I know the Twitch ads can be a little bit long sometimes, so we'll give it a second. But if you're gunning for something to do, get your IDE of choice open. I've got VS Code. I love VS Code. And if you want to be really ahead of the game, make a virtual environment and activate it, and then we'll do some installs. Hi, I'm not bad, thank you. I hope you're doing well as well. Welcome, welcome. Awesome. So let me share my screen. I reckon we can kind of slowly start moving. What I'm going to be doing is sharing my VS Code, and I'm only on one screen today, which means it might be a bit narrow. There we go. But hopefully it's all legible. If you want me to, oh, that's not right. I'm in the wrong tab. This is maybe too big now. I don't know if this is too big, but if we need to play around with like font sizes and stuff to make sure it's legible and readable, we can do that. I've got a question. What are my opinions on the new mascot? I love it. I mean, I was dead certain it was going to be a jellyfish. Jellyfish are so cool, and I'm very excited. I love the art style. I mean, the art style always hits different every season, but I'm a huge fan of it. The kind of like, I don't know how to describe it, but I just like the aesthetic. I like the aesthetic. Yeah, I'm a big fan. I'm a big fan. Jewel, I think, is like an unusual name as well. But yeah, it's cool. It's cool. Awesome. So right, let's get started. Because otherwise I'll talk for forever, and then we will run out of time, and that would be sad. Although not that sad, because like I said, it is well, it's been a long day for me. Maybe you're just starting, but either way, we're taking it chill. And I'm now making, by the way, a virtual environment. If you haven't seen this before, this is like a pretty useful thing to do to keep all of your packages and installations nice and organized between projects. I do it this way. You maybe haven't seen like this bit before, but I do it this way so it's named something different in my terminal. I like that. And I'm going to activate it as well. This command is going to differ depending on the OS that you're on, and also potentially your terminal as well. This is what works for me. If you're struggling with it, let me know and I can try and help you debug, although I am potentially shamefully a Windows user. I know that Ryan was just streaming. Ryan is also a Windows user. I think we're very much in the minority, certainly amongst the MLH crew. So yeah. Okay, so we've got a virtual environment. We've activated it. Hopefully everyone's got to that point. Oh, and hopefully you made a new project, new folder and so on. I'm not going to bother with Git, by the way, but if you want to, you could initialize or do it in the command line, your choice. Yeah, and we're going to do some pip installs, and we'll make it quiet because why not? And FairLearn is the big one. This is what we're going to be using to analyze how fair our data is. And I'll talk a little bit as we go through it why this matters. I think probably most people have a bit of an inkling about like why this is important. And I think most people have experienced life being a bit unfair, right? And that's maybe an aspect of life, but when we are building models, we want to make sure that they are not inheriting the bias and unfairness inherent in the world. We want to do our bit to make sure that that what we're doing at least is fair and kind and good. And so The rest of this is basically scikit-learn, probably you're familiar with, but the rest of these, pandas hopefully as well. But these are all kind of just like visualization stuffs. And I won't go into too much detail on them because I really want to focus on yeah, the data and like the challenge of like what is fairness, why do we care about that? So yeah, we'll let that run for a bit. It's not going to say anything because I put this little quiet tag in, but you can not put that in and see what it's typing up. And what I'm going to do in the meantime is make a little like experiments. And this is just a little Jupyter notebook. And I'm going to select our fairness virtual environment, which is the one that we're using here. It's the one that we just kind of, well, we're installing things into. And we should do some imports. So let's import pandas as PD, import numpy as NP. These are all kind of like pretty basic things that we use. Seaborn is, of course, a visualization tool, matplotlib as well. Probably most people have heard of matplotlib. But both of these are really nice for making pretty graphs. And I had someone in one of my streams, I think on Sunday, I want to say. It was Sunday in the UK, so maybe it was... No, it was probably Sunday most places in the world, actually. They were like, oh, did you love visualizations and whatnot? And I was like, oh, yeah, I do. But I'm not always very good at them. I don't sometimes have the patience to play around to get... I don't want linear model, actually. I don't like suggesting that. I don't sometimes have the patience to play around getting exactly the kind of... the beautiful compositions and layouts and colors. So not the best for that. But then, you know, you do have tools like Seaborn. They do a lot of the heavy lifting for you. Some of our plots today will be really nice because of that, and some of the like slightly trickier ones will be less nice. And that's okay, because as long as it's getting along what we need to do to make sure that we're on the right path, it's kind of okay. Cool. So these are probably like quite a lot of lines. You might be like, oh no, so many things, but actually it's going to be okay. It's going to be okay. Yeah, like I said, probably most people have scikit-learn. Yeah, it's useful. It's for building like ML models. If you haven't, that's okay. It's not really like core to what we're doing, which is using fair-learn metrics. But it is ultimately like worth learning, right? Worth learning. And as long as you have like a basic idea of like what a machine learning model is, like the fact that you're trying to fit some kind of, I guess, some kind of like pattern in the data and trying to kind of use that to predict or understand the data, then you should be okay. So don't worry if some of this is very new to you. As I've said before, it's going to be nice and relaxed. Yeah, so right now we're importing various different metrics, and these are, let's get that in there, metrics. And these are what we're going to use to look at our data and think, is this actually like good? Has this got some bias in? Maybe it does, maybe it doesn't. And we'll run that, and it's going to want to install IPyKernel, which I always forget to do, but it will do that for a bit. It's just a package needed to run cells and notebooks. You could also do this in just a simple Python file. That's your choice. Awesome. Okay, cool. It looks like we don't have any questions. If you do have questions, just drop them in the chat. I'm kind of keeping half an eye on it. Like I said, I'm on one screen today, so it's a little bit harder than normal, but I will do my best. Oh, and I forgot. I mean, I said it's a long day, and you can tell because I haven't said check in. Remember to check in if you have not checked in yet. I'm gonna pop the link in the chat. It was also in the Discord announcement. So if you've checked in already, do not worry. What's going on here? We'll fix that in a minute. The check-in link is in the chat. It's also up on the screen right now. Please do check in. It helps you get points and also stash. well, swag rather, sorry. And we all love swag, right? So definitely check in. Definitely check in. Worth doing. Worth doing. It also helps us know which streams you're enjoying. Like if we know, oh, loads of people are going to the stream and really loving it, it means we can do more like that. So it allows us to do even better and more exciting streams for you. We got a question: which is better, Jupyter Notebook or VS Code? I like VS Code. I guess you can use like Jupyter Notebook online, right? But this is like a notebook itself. This right here. So I guess kind of both. Probably like slightly different applications, but you could equally also, like lots of people like, can I use Colab for this? And the answer is yes, you can use Colab. I don't think there's anything that we're doing today which you couldn't do in Colab just as easily. So it's entirely up to you. Yeah. Cool. What else are we saying? Stash sounds so much better. Yeah, Stash is what at least I think most hackathons in the UK call it Stash, not Swag. I think Swag is a slightly more American word, maybe. If you can't tell from my accent, I am British, so it's slipping through there. But Swag is officially what you get for joining these streams and so on. So we'll call it Swag for now. You also noticed that I kind of painstakingly maybe saw a grimace on my face as I typed this, but it saddens me that so many packages use American English spelling. It makes sense, I suppose. The tech world is quite American in many ways, but and maybe we'll talk about that as a point on bias. But yeah, there you go. Cool. The Brit coming out with the stash. So true, Steve. So true. Yeah. In it. Oh yeah. Okay, right. Let's stay on track. Where were we? Let's fix this. This is not that. It needs to be there. That's ridiculous. Why did I do that? Who knows? Okay, and while that's running, and hopefully it's going to run successfully, here is the data set that we'll be using. Feel free to go and read about it. I popped the link in the chat. Hopefully you can just click that link. And I'm heading along to it now myself. I'm not going to stream it because that would be too much swapping streams and so on. But it's basically like a census data set which measures income for individuals. And so obviously this is like potentially very interesting because income is used to make loan offers, right? If you're trying to buy a house, maybe get a mortgage, even things like insurance on your house or your car or your properties, your possessions. So this is an interesting thing, right? Because there's some protected characteristics. Typically, in most countries, there are these regulations around characteristics, and these include things like your ethnicity, your sex. There's a huge list of them. I think your faith as well, whether disability and so on. And these are things which people should be treated equally across, right? And like I said right at the start, I think all of us have felt at some point in our lives like, oh, this isn't fair, right? This isn't maybe right. And what we want to do is we want to make sure that actually, okay, when we're building models, right, they are going to learn the bias in our data. And if we're building, for example, an insurance like model that helps kind of quantify how much people should pay for their insurance, or like a mortgage calculator that takes in someone's data and then says, oh yes, this is the mortgage offer that we can give you, the loan, whatever. We want that to be fair, right? We don't want someone who is identical except for their ethnicity or their disability or their sex or whatever, right? We don't want any of those things to cause them to be offered different amounts, right? Because fundamentally it shouldn't be based on that. And so this data set is going to be really useful for us, and I think we should load it up. So without further ado, let's get going. So let's do df raw. So this is our data frame, and we're going to do pd.read csv, and then we want to type in the URL for this data, and it's not going to be the URL that I just pasted. It's going to be this URL, which looks very similar, and it is quite similar, but it's not exactly the same. And so you pop that in there, and that should be good. Okay, and then we're going to do a little bit more in here. We're going to say names equals, and then we want to put in a nice long list of column names in here, right? And these are going to be like specific to the data set. So make sure you kind of type these out yourself correctly, ideally. And then lots of these, in fact, nearly all of these we won't use, so don't worry about them. It's just so that we've got some like clean data to work with. That's actually correct. Marital status, right? This is another thing, right? People shouldn't be treated differently based on whether they're married or not. It probably would be reasonable to treat people differently based on their occupation, because someone who's earning a lot more money, like we said, is going to be eligible for different loans, but their race or their sex, like I'm just typing in now, are not going to be suitable things to base a loan on, right? And I think that makes sense. I think hopefully everyone like appreciates that that's actually the right way of doing things. So that's just predicted a whole load of different things, and that's actually right. Okay, so these are good. Now this is kind of clunky, and I don't like it. It's very unreadable, and so what I'm going to suggest is that we actually do columns equals, and then paste that in there. And this is the link again. This is the link which I pasted in the chat. The second one. Let's get that out as well and just say URL, and we'll wrap it in quotes. Cool. And so we'll get rid of the quotes in there, and we'll say URL. We'll say name equals columns, and then we'll say, yeah, sure, any values with a question mark, and we'll skip the initial space. Sure. So, and let's check that we've done this correctly. We will just look at the head. This is the first 5 lines by default. We could also change it to be 10 or whatever. And we can see, great, we've got people's ages, right? Another thing that you shouldn't discriminate on. And we've got education, right? Lots of things going on here. And this is interesting, right? We've also got their incomes. So that's cool. Now, let's do a bit of data cleaning. Again, I'm kind of going to speed through this a little bit because it's not really the crux of what I want to get to. Again, if you're like fairly familiar with pandas in particular, or data and ML as a whole, probably like lots of these things are fairly familiar. And what we're going to do is we're going to make a new column. We're going to call it high income, and we're going to say, right, depending on whether someone's income is larger than 50K, and this is actually just so we need a capital K in there. Maybe just highlight that capital K in there. This is just based on this existing column, right? Whether someone is above or not, and we're basically just rewriting this column to be like a clearer indicator, because it's going to be nicer for us to work with than dealing with a string, right? Text is less fun. And then we're going to just get out the columns that we actually want. So that is sex, that's race, and high income. So these are kind of like some key characteristics that are often talked about as like the biggest ones, which are historically certainly have been not great, right? In terms of bias. And so let's run that, and great. So this is the first 5 lines. We just got the head out, and we can see, okay, we've got people's sex and their race and whether they are high income or not. Cool. So maybe let's get some quick stats. I'll quickly give a pause. Any questions? Hope we're all happy. I will give it a quick moment. I'm faffing about with my own screens and bits behind the scenes. So, but yeah, let me know if you're kind of happy with where we've got so far, if you're caught up. So we've loaded in our data, and let's get some key stats out, right? So maybe we'll say base rate, and we'll say we want to work out how many people have like a high income as a proportion. And so we can do that by saying, okay, let's get our data frame, let's grab just this column, and let's get the mean. This is because it's an indicator, i.e. it's either 0 or 1, this will just give us the proportion. And so we can print this, we can maybe give it a more descriptive name, overall high income rate. And we'll run that, and it's 24.08%, great. So 24% of people-ish have a high income, according to this census data. And this census data, I think, is from like 1992 or something. And we didn't import this earlier, but let's import tabulate. And maybe it's relevant to mention the year, because obviously, historically, there has been bias in our data, right? The wage pay gap and so on has depended on personal characteristics like these. And that's not right. That's not, at least in most countries, right? In the US, in the UK, in the European Union as well. And I'm not too sure about others, but I'm like fairly certain that this is a common thing in many countries. It's considered bad, right, to have people being paid different amounts based on things they can't control about themselves. And so I won't get into the kind of the nitty gritty of like the ethics and morality, but I think it's worth pointing out we are missing a square bracket there. But I think it's worth I think it's worth mentioning it because I think it's important that we consider these things. And so that's kind of the crux of this, is like, okay, well, let's say hypothetically, right, in this case, this is an assumption that I'm making, but we'll see it in a minute. If we have some data which is biased towards a certain group of people, like, what can we do about that? And so this is where FairLearn comes in. And so it provides us not only some metrics to calculate whether a data set is biased potentially, but also whether it is fixable, right? Maybe we can even fix this. And so it provides us with a toolkit for that. And I'm going to just quickly throw in some print statements here. You can, I know I'm going quite quickly, but I'm just conscious of time. You don't have to use tabulate. Tabulate just makes this a pretty output. You could literally just go print sex rate. And if you ran this, you'd get this, which is exactly the same as this. I've just formatted it ahead of time for the sake of ease. So let's have a little look at this. So this is, they're saying that 89% of women are not on a high income and 10% or 11% are. And this was 1992. So maybe that's useful context. So this is not current. And then we've got 69% of men and roughly 30%. So it's nearly 3 times as many. And then by race, we can see as well, there's some kind of big distinguishing factors, right? 25% of white people, whereas 12% black, and so on. So this is already giving us a bit of an indicator that maybe our data isn't great. And let's do a quick visualization, maybe. So we'll do sex rates. In fact, I'm going to copy and paste one in as well. This is just for like demonstrating purposes. You don't need to write this out. So don't worry about writing this code if you're coding along with me. But this is just a plot to visualize these stats here. So just looking at the sex, right? So I mentioned this like almost 3 times as high rate of men having high income. And we visualize that, and you can see, right, like it's just over 10%, just over 30%. It's nearly 3 times as high, and that's pretty big, and that's not great, right? If we're trying to do like loan calculators or mortgage calculators or any other number of things, we do not want this to be influencing our model. So let's build a model first, which is not great, using this biased data, and then see if we can do something about it. So we're going to get our data, and we will basically separate it out into our features and variables. So we want to drop all of those, and then this is our feature of interest, and then we want to split into split into a train test split. And Copilot is predicting for me. This looks pretty good. This is using train test split. This is from scikit-learn, but basically what we're doing is we're taking up our data and we're chopping it into sections. So let's make it 25%. And random state, sure, it's like a random seed. We'll also stratify it. So let's add that in stratify. This just means that the rate of high income will be the same across both splits, which is important because it's the rate that we're actually kind of interested in here. And then let's make sure that we identify our column types. So categoricals are going to be x.select data types, and we will just get object, and then we'll get the columns. And then we'll do the same for numericals. So it's already predicted that for us. It's literally just the same thing, but with number, and we rename it something different. And then we will pre-process. And this is going to be using, again, oh, there we go, some tools from scikit-learn. And those are one hot encoder, which is for our categorical data, and obviously our numericals can kind of stay almost as they are. And this is because obviously if you've got categorical data like strings, for example, like red, green, or blue, like we can't train on that. Whereas we can split it out into common, where if it's red, it's got a 1 in that column. And so on. So this is again hopefully fairly familiar to lots of people. This is kind of some fairly basic machine learning data pre-processing. So if you are not like super familiar with this, I'm sure there's going to be some other people doing streams on like ML. I think there was a stream on Intro to Python. So if like you're like, oh, I barely know what Python is, do not worry. That's okay. That's okay. We named this like this. Okay. Perfect. Right. Okay. So now we're making a pipeline. The other thing actually to mention is that it's beginners week next month. So there definitely will be some like beginner ML courses in that, I'm sure. If not, let me know. Well, maybe, I mean, you won't know till later, but like if you really want one, let me know, because I can run one for you. Perfect. Okay, so what we're doing is we are making a pipeline to fit our data and then train our model. Let's do that. So we will fit and train our model, and then let's check the accuracy of our model. It's going to be just baseline.score, nice and intuitive, and then we'll print that out. And let's run it. And it might take a few seconds, probably not too long. Cool. Okay, so accuracy 84.38%, pretty good, pretty good. That's all right. I mean, it's not like brilliant by any means, but like it'll do. It'll do as our baseline. It's a very simple model. And so now let's see like whether our model is biased, because obviously we saw that our data has different rates for men and women. Is that going to be a consistent thing, right? In our model's output? And this is the idea that basically our model is only really as good as the data that we put in. And this is a bit of a spoiler, but it will not. It will inherit that bias, and we can check that really clearly. So what I'm doing now is I'm generating some predictions, and then I'm extracting that sensitive attribute, right? The sex, and this could be race or whatever else, for the test set specifically. Awesome. Okay, and then we're going to do two different audits, two different like tests basically, and we will use metric frame to do this. So this is using Fairlearn, I recommend like going and reading the docs. They're pretty good from my experience so far. Some of them are like slightly out of date, which is a bit weird. They've got some like notebooks which you can like walk through, which also like don't fully work. So bear that in mind. But like in general, I think it's pretty decent. I found it fine looking through it myself. Okay, right. And so let's maybe we'll just run this now actually. So I'm gonna just copy and paste in a print statement. Again, you could just print this, but this is my by group worth doing, because that's what we care about. And I'll run this, and then we'll do the other stats that we kind of looked at. I think actually we maybe already imported these. I can't actually remember, but maybe we did. Okay, so we can see this is just the selection rate, right? You can think of this like, okay, if you were gonna pick between the observations, right? In this case, people, but the rows of the data based on this characteristic or this characteristic within the sex variable, like what's the rate that we would pick them? Like what's the rate that we would actually see them being high income? And so it's not quite 10 and 30%, it's 7 and 25, 26%. But this is bad, right? This is not equal by any means. It's not great. And we can actually check whether there is we can look at like basically some more difference metrics, if you like. And so we've got the demographic parity difference, and we've also got, and I'll type these out and then explain. I'll come back and check the comments in 1 second. So maybe I'll type out this one and then we'll check the comments and then I'll type out the next one. Perfect. Actually, maybe I'll just copy and paste this and then we'll just edit it. So the next one that we want is EO, and it's going to be, oh, not EOF error. No. And then we want the equalized, again, the American spelling breaks my heart. And is everything else here okay? Yes, okay, fine. And then we'll just print these again. I've got some print statements prepared, saving on a bit of typing. We're halfway through, so I think, and we've got 30 minutes left. This is going fine in terms of time. Okay. You can see my English spelling come through here. Oops. So let's check. What extensions do I use? I actually don't even know what extensions I've got on at the moment. I mean, Copilot is the one that's doing all of like the predictive stuff. I've got like a whole load of random things in here. I use a lot of R, so R in VS Code is a little bit cursed. Some people judge me for that. I use a bit of Rue code, which if you went to Ryan's stream earlier, he was talking about that. But yeah. I use a few. Are there any in particular? Are there anything that you're like, oh, I don't know what that is? Can maybe help out if you've got like a specific question. But yeah, let's take a breather. I know we went through that really fast. I'll give you a chance to catch up. I'll leave this code up. Feel free to ask any questions. Any questions coming in? No? Okay, it looks like we're fairly happy. In that case, I will explain these two metrics down here. So the first one is demographic parity. And this is basically asking, does our model give positive outcomes, like, for example, granting someone a loan, or in this case, like predicting them as high income, which is like our proxy for a positive outcome, right? To different groups at the same rate. And if not, what is the percentage difference? So if this metric was 0, it would mean that there is no difference. If it was 1, it would mean there was 100% difference. All of the time it picks one or the other. In this case, we've got 18.7%. Oh, I've got hiccups. I'm drinking my water too fast, but do stay hydrated, even if it gives you hiccups. It's important. So this is a difference of 18.7%. That's not great. 18.7%, nearly 20% difference. It's not great. So a big gap here shows a bias in the outcomes, right? So we've got our input data and we've showed that there's differing rates, and that's maybe a bit of bias. And we also showed that that translates to bias in the output. And this is really key because lots of regulators will be saying, okay, well, obviously we want your input data to be unbiased, but actually like your outputs need to be unbiased. That's kind of the thing they care about, right? They're saying like in any tools that you use, make sure that they treat people equally, and so the outputs are the things that are really often cared about and regulated. And the other thing that we've got here is equalized odds difference, and this is basically saying, do different groups get equal error rates? And it checks two things. So your true positive rate, i.e., if like 2 people would succeed, get a high income job, do they actually get that? And also false positives. Are false positives equally likely across characteristics? So if 2 people wouldn't get high income, do they actually both get wrongly approved as well at equal rates? And this maybe doesn't make much sense, but basically what we're saying is when we make mistakes, dealing with people from different groups, different characteristics, ethnicity, for example, do we make mistakes equally across those groups, or do we make a lot of mistakes with one person, or one set of people, right, one group, and none with another? Because that would probably imply that our data isn't great either. And so that's a really important thing to be aware of too. And we can again produce some graphs, and I'm going to copy and paste them in for the sake of time. So let me do that. Actually, I'll type out the start of this, and then we will paste it in. And we're going to be using alter, which is, again, like actually not a tool I've used a ton. I'm a little bit more like used to matplotlib, but it's kind of nice. It's a little bit interactive, which is cool. I think it works nicely with Streamlit as well, which if you've seen many of my streams, you know I love Streamlit because it means I don't have to do means I don't have to do front end or really much back end either, if any. It kind of handles everything for you. I recommend it very highly for hackathon projects. It helps you get started super fast. And if you really care about your idea and not necessarily how, let's get those columns right. It should be selection written like that. Then yeah, if you really want to work on your idea and not necessarily, you know, the art of the front end isn't something that you love doing, then it's, you know, okay. And well, not just okay, but I love it. It's really useful. So this is just a bit of like pre-processing to get the data that we have into the right format and making it kind of pretty. And now I'm going to paste in some chart code because it's a bit of a faff to type out. This is the code. If you want to, you can take a screenshot and then type it out yourself. But I'm just doing this so that you can see, not actually because it's super important to the demo going forwards. And if you don't type this out, you will be completely fine as well. So no stress, no stress. We got any other questions in the chat? We've got no thanks, no problem, no problem. Looks like everyone's happy. And we've got 20 minutes left. Let's see if we can finish this off. So we can see that not only is our data biased up here, but also actually when we plot it, again, using this nice pretty graph. Oh, look, it has pop-ups. The tooltips, so good. There you go. This is not great, right? This is what we saw up here. Like in theory, if this was like a, you know, like a mortgage tool or something, it would be giving out mortgages to men over 2 times as much, right? That's not fair. That's not right. So let's see what we can do about that. All right. There's also like one other quick chart that we can make. Again, I will paste it in. This one is like fairly nicely commented actually. And again, like do not type this out. It will be a little bit of a waste of your time. But if you want to, I'll quickly scroll through it. It's got nice comments, so hopefully it makes sense. This is because I had some issues earlier, but you can ignore this actually. Okay, so these are our different rates, which actually kind of these true positive and false positive rates are what comprise of this metric here. If you want to learn more about the metrics, you can Google it, Fairlearn, and talk about them a fair bit. But hopefully my explanations are sufficient for this. So we can see actually this is not too bad. This is obviously like not great. This isn't great either. This is, I mean, yeah, it's not great, right? So we've got really high true positive rate here, which basically means that if a man is actually like someone who should be predicted as having a high income, they are, you know, pretty often done so, whereas only half the time are women. It's about a 10% point difference. The false positive rate is also higher for men, which means if they don't deserve, you know, the high income, if they, you know, they shouldn't be predicted as a high income, or like, for example, maybe a better way of phrasing this would be like if they didn't, if they wouldn't be like eligible for like a mortgage, are they predicted it anyway, right? If they should get it, and the answer is they are much more likely. So that's bad as well. So all of this, these visualizations, the point is to show that actually, like we can use these metrics from Fairlearn to go, oh, the bias in our input transforms and is still present in our output even after training a model. Okay, so what we're going to do is we're going to build some like a mitigation kind of model that deals with this. And the way that this is going to work is it's going to do grid search. I'm pulling in some like warning exceptions because when I run this, sometimes it just pops up with a whole load of warnings, which I don't really care about. And I would sooner just hide them for everyone's viewing sake, but you don't really need to. You can leave them if you like. So let's look at demographic parity, because this is kind of what we really care about, right? Like we want men and women to be treated equally. when we're giving them loans, for example. And so let's pull that in, and then let's pull in. I think actually we already have pipeline. I'm going to finish typing this just in case we don't, because that would be awkward later. And then we need linear model. I'm going to import logistic regression. We definitely actually already have logistic regression. But just so this is a nice piece of standalone code that if you wanted to use, you could, we'll put it in there. So the first thing that we're going to do is we're going to make our pipeline, and this is going to be kind of basically as before. We're going to do some pre-processing, and we're going to then logistic regression. We're just going to like shove our model onto it. So, and this is, we're going to call it like fair pipe. What do we have the other one called? It was called like base pipeline. I can't remember what we called the other one, but we did make a pipeline already. And it's the same process. So again, we'll use pre-process. This is the one that we've already kind of defined. And then we'll use logistic regression. We do not want this. No thanks. We do not want this. We want, and this is just some of our model mumbo jumbo. So do not worry too much about this, but this is like our setup for our model. And then this is the big thing, and this is kind of what I really want to get to. Let's get a comment in there. We're going to add a constraint and do a grid search. And probably you're familiar with the grid search, but it's when you're trying to kind of build a model, you often use it for hyperparameters. You're trying to work out, okay, no, for parameters rather, you use hyperparameters often when you're doing your grid search. You're saying, okay, I've got all of these different values that I can try, and I want to make my model as good as possible. Like, how can I do that? And so you try a bunch of different parameters in a grid, maybe, and you see which one is best, then you pick that best model. But what we're doing is we're adding a constraint, and the constraint is going to be basically make the demographic parity good, right? Get it as close to 0 as possible. And so this is going to be called, we're going to call this a mitigator, and this is using grid search. Grid search is from Felon. This is from their reductions module. I recommend giving it a read. They've got loads of different things that you can do to make your models fairer. And I think that's super important if you're dealing with like especially personal and sensitive information. Fair pipeline. And it's Colab's predicting well for us. But yeah. So if you're dealing with sensitive information, if you're doing like a healthcare app, for example, at a hackathon, right, this is going to be really useful. And maybe you went to my stream on Sunday, or maybe you didn't, but I spoke a little bit about like decision making and how we use data to do that. And we spoke about it. We don't want that. We spoke about it purely from like a Bayesian statistical perspective. That's a hard word to say. And we said, okay, like, let's use data to inform our decisions. And that was really cool. And we got some really like cool things happening as a result of that. But actually, and also going to have just in brackets here, plus silence warnings. But actually, that's only good if the data that we have is good and fair, right? And so I hope that makes sense. But I think when you're at a hackathon, right, it's worth thinking about your data and how you use it, because sometimes people just download a data set and they're like, oh, this data is great, and then they just use it. And it's like, okay, fine. But I think if you actually want to build something meaningful and impactful, this is worth considering. And there's some projects where you are, kind of inherently, you are inherently dealing with like some really sensitive stuff. Health data is often like this. There's like a whole load of other data that is going to be like this, right? Financial data, for example, like the stuff we're looking at now, people's salaries. So bear it in mind. Do bear it in mind. I really do recommend having a little thought about it. Let's get an equals in here. Again, this stuff here is just what I have found to work when running this, that avoids getting as much kind of mess in my output. But you could ditch all of this warning stuff, so don't feel like you have to use it. And then we will do mitigator.fit. You don't want to ditch this. This is the important bit. And then we'll do xtrain, ytrain, sensitive features equals x
train, and then our sensitive feature is going to be sex. And you could, again, like you change this to race or ethnicity or whatever. And that would be great. That would work too. So we're fitting our model after doing the processing and setting up the kind of construction for our constraint, which is this. And I'm going to have a plot later, which will hopefully make it super clear as to like how this works and whether it works, and so on. So this is, again, much in the same way as before. And I guess like I'm hoping this is all going to be like fairly intuitive if you used scikit-learn before. Okay, and then we will do, yes, accuracy with reweighting. Oh, reweighing. I think grammatically reweighting is correct. Reweighing. You reweight it, right? I don't know. Maybe I'm wrong here. Okay, so we'll run this, and it will probably run for like, I don't know, 10 seconds or something. And we're doing 10 little checks in our grid. So we try 10 different, no, sorry, 100 different models. And if you change this to be lower, probably your results will be not so good. If you change this to be higher, they'll probably be better. I think 100 is a good middle ground that will give us some okay results. I was completely off with 10 seconds. Wow. And so, yeah, we'll let that run. What we're going to do is we're going to set up a new audit. And it's going to be basically the same as our previous audit. I think what we want is, let's grab this one and this one. So I'm just grabbing the selection and the demographic parity difference, and I've copied them, and I'm going to just paste them down below. Okay, so we finished with an accuracy of 79.68%. So it's a few percentage points lower overall in accuracy. What did we get? We got 84%. Okay, but that's expected, right? If we've got a constraint, we're going to get some trade-off, and that's kind of like ultimately okay, because we want our data to be fair, right? And it's pretty pointless. I will call this audit and reweight. Yeah, this would be pretty. It would be pretty pointless fitting a really accurate model that just like discriminates and is unfair and biased, right? And there's lots of thought going into like, oh, like how do we treat bias? How do we make models fair? With generative models as well, so your LLMs and so on. Obviously, this is a big thing. So if we rerun this, and let me print statements, but mine are slightly more complicated. Oh, I've named something different here. Let's, yeah, there we go. Just be slightly more descriptive with our names there. And so, this hasn't worked. Okay, interesting. Let's have a little think about what's gone on here. I know what it is. So we just copied this and we didn't update it. So these are exactly the same stats that we had before. I did think, I've forgotten something, haven't I? And I hope you're all going in the chat. Yes, Quinn, you did forget something. Let me check the chat, actually. How are we doing? Seems like we've got some happy hackers, some quiet hackers. That's always good to hear. Well, I mean, I love hearing what you're saying, but if you're quiet, I'm going to just assume everything is great. Okay, this is much better. So again, it's still a bit of a difference here, but actually, this is much better. This is a demographic parity difference of 0.023 or 2.3%. Now, given we had a parity difference of 18.7%, nearly 20%, we've gone down by nearly, not quite, but nearly a factor of 10, which is really, really good. And we only lost, I don't know, like 3% in accuracy. So that's pretty good. And I'm just going to, again, shamelessly copy and paste it in a quick plot. If we run this, it's going to be unhappy, apparently. I don't know why it's unhappy. Okay, well, what I'm going to do is I'm going to... we've got a few minutes. Let's do some debugging. Okay. So this is what it's unhappy about. Series.rename got an unexpected keyword argument columns. I wonder if when we defined this, we maybe did it. Okay, yeah, this code is assuming that we've got columns inside as the metric, I think. So let's, I'm not sure if this is going to be what we need, but I think this maybe will work. If we do selection rate, so I'm just defining a little name for it here. This is just a basic dictionary, right? And then we'll run that again. And then we'll run this again. Oh, look at that. Look at that. Wow. Okay, so before, kind of ridiculous, we can see that we had these huge disparities in selection rate. And we can see that it's massively dropped, right? This is much, much fairer now. So this is good, right? This is showing that we're mitigating it much better. There's still a little bit of a difference, but compared to this is pretty good. And then there's one final visualization that I will copy in, and then I think we're pretty good on time, actually. So we'll have some time for questions if people have them. And I've also got some further resources. So this is just a plot. Hopefully, again, this will run. And this is just going to plot all of the different models that we trained using this grid search. So remember when I said, oh yeah, we up here, we basically try a bunch of different models and then we see which one is best. And this works, like I said, we've got this constraint where we're basically saying as much as possible, be fair. And so it's got this metric, right? Like any other metric, like accuracy or whatever, which is optimizing to. And you can think of it kind of like an adapted loss function, because that's basically what it is. We've taken it and said, we don't just want you to improve your accuracy, but we actually also want you to improve it according to this constraint. And the constraint is that you should have as low as possible demographic parity difference. And so when this is run, perfect. So we can see here our accuracy up here and our demographic parity difference. And basically what we want is we want this to be as low as possible. We want this to be 0 if we can, right? So this is 1 up here. This is like very bad. Really, really bad, actually. It's kind of impressively bad. What is, in fact, this has got 50% accuracy. What this is doing is it's just picking men all the time, basically, probably. Yeah. And what it's trying to get, right, what we want ultimately is we want 100% accuracy up here, or as close as possible, right? That would be overfitting, with 0 down here. And so we're trying to just get up in this direction, like, that way. However, we don't want to do too much of a trade-off on our accuracy. So you can see if we dropped all the way down here, we'd probably be like sitting down here somewhere in accuracy, and that's not terrible, right? And you might make the claim, well, we should do that, right? Maybe we should. You could also just run this more, and you might get better models out here as well, just like above this curve. But it certainly seems like this is kind of where the loss function has kind of stabilized, and this is pretty much the best model that we have. This red star here, this is the chosen model. You can see this is not very clear, but and so hopefully you can see that actually what we're doing is we've given it an additional constraint. So we're not just saying, right, make the accuracy as high as possible. We're also saying make the accuracy as high as possible, and then the demographic parity difference as low as possible. So I think we'll maybe like kind of look to wrap up here. Oh, I just minimized that. I realize it's probably not gonna make it very clear for you all. But yeah, and this has been a rapid fire speed run of looking at some data and thinking, oh, this maybe isn't fair. We've got some outputs which aren't fair. How can we fix it? And we've done that, and we've done that by retraining it with a constraint. Now, lots of people will say at this point, like, oh, like I've got a question. Why don't we just delete those columns, right? If these columns are sensitive, which they are, like sex or ethnicity or marriage status, marital status, whatever, why don't we just delete them? And you might think, okay, that's a good idea in principle, but then you might realize that actually there's correlation between all of your features, and just deleting them won't work. For example, people of different ethnicities often, right, in the real world live like closer to each other. So you have like areas where people are more likely to live based on their ethnicities, and you see that like all over the place regionally. And so if you had, for example, a variable in your data, a feature which was like, okay, like postcode or like coordinates or something, or like some kind of location, maybe you were doing like house price in like insurance, like the cost of insurance for houses, or even just like like mortgages, stuff like that, right?
you very easily could end up deleting this deeming like, right, done. We've deleted it in the input, so it's not going to be present in the output. But actually, the bias will still be present through the correlation with your other features. So the other thing you might say is, well, can I just remove the correlation with all of the other features and then delete the column? And I think you could do that. And there is actually I'm going to minimize my screen, and I'm going to stop sharing, and I'm going to present some stuff very quickly. We've got 3 minutes. We can do it, can't we? I believe in me. Do you believe in me? I hope you all do. I'll get to questions. I saw we had a couple a second ago. So this is like just the docs from Vela, and I recommend you read it. This is actually what we've been using today. And if you head along to API docs, you can find what we've been using. So we've used metrics quite a bit. You can see down here the demographic parity difference. We could read about this if we wanted, but the thing which I was pointing out, which is in reduction. So this is how can we mitigate against disparity or unfairness. It talks a little bit about the maths here, which is cool. You can also, I think, if you use, let me check my notes, because it's actually not something that I've used, but there is a different one of these for removing those correlations, right? I think I can't remember what it's called. I'm surprised I had time to get to this point actually, so I didn't prepare it that much. I think I don't know. I mean, I've heard very good things about exponentiated gradient, which is, I think, a similar way of like optimizing, and it's a little bit more flexible than grid search, and it uses constraints as well. I think there is a way of reducing correlation. Let me search it. Let's see if it's here. We'll just have a little look. I might have misremembered actually. Maybe they don't offer this out of the box. I'll tell you what, if you're interested in this, at me in the Discord and I will find it for you later and send it, because we're out of time pretty much. But yeah, I mean, basically my point is that there are a whole load of other ways that you can mitigate, and depending on your data and your problem that you maybe have, you can look at different things and pick the one for you. So this kind of like decision making is really important to have consciously in your mind, right? Because when we are building models, we are ultimately, if there's going to be an output that's affecting users, we are influencing and affecting people. And you've got to remember that there are people at the other side. And so we must do our best to be fair. And even though our data might be imperfect, we can still produce good and at least better, maybe not perfect, but better, fairer models. So I hope that's really exciting. And I see we've got some questions in here. Let's see. Am I still at university? Yes, I'm doing my master's. So I am still at university. But I feel like I've been at uni for ages now. Yeah, if you've got questions about university and like studying and so on, like feel free to ask me. I like my research. I like my academia. I like learning. So feel free to ask away. I'm glad there's some belief in here. And tuned in late for this one, we'll definitely check the VOD. Yeah, you can do that on YouTube. And also, if you enjoy it or if you've got thoughts on how it can be improved, generally, if there's you want to see more like this, please let us know. You can do that at amlh.link/GHW feedback. The link is in the chats and also on the screen. I'm now late. Let me very, very quickly check the schedule. Schedule says Tetris mini event is happening now. So head along to the Discord, go play some Tetris, super fun. I'm terrible at Tetris. And yeah, as always, it's been a pleasure having you. I hope you've enjoyed this speed run through, and please let me know what you thought at the feedback link. I love to hear what the hackers think of what we're doing. And with that, I will bid you good night, or potentially good morning or afternoon, depending on where you are. I'll see you later. Thanks for joining me, and happy hacking. Bye.